All right, so in this lesson, we're going to be modeling data using logarithmic functions. All right, so the general form of logarithmic regression model is this here. All right, y1 is approximately a plus b to the ln x. All right, so a couple things I want to point out before I go into the first example is that in terms of logarithmic functions, in the previous unit, we had y equals, just write that up here, y equals a log x, and we had y equals a ln x. All right, so these are both logarithmic functions. And for the purposes of this course and the previous unit, we just assume that these are both the same, right? Which they both have this, they're both logarithmic functions, and they both have generally the same shape. Now, there's a couple things I want to point out. Is that when it comes to modeling the data, we're actually only going to use this one here, the second type. All right, so ln x. We're not going to use log x. All right, so you're going to use this as your logarithmic function. And as well, you'll notice here that it has a plus b times this, right? So we've added in kind of another parameter or variable. This a here, what it does is that actually allows us to move the graph up and down, all right? So if you recall, with these two here, the graphs themselves were either going to look like this if it's increasing, or like this where it's decreasing. But it always crossed here at an x-intercept of 1, right? Now, what this allows us to do with the added parameter is it allows us to actually take this graph and shift it up and down. So the x-intercept is no longer going to be necessarily 1, all right? It can change, right? Because these graphs will be moving up and down, if that makes sense. All right, so yeah, so we got two parameters here to work with, not just the one there that you learned about in the first unit. All right, cool. All right, so let's just jump straight into this first example here. So I've got this data, and yes, so this is table below shows data for 5 recently discovered fossils. All right, so this is the carbon-14 percentage and the age in years of those fossils. All right, so let's input that into our Desmos. All right, so I'm just going to add the table. So my x values are the percentages of carbon, so 95. 79, 7. So 50, 191, 8,000, 10,824. All right, so the next thing I want to do is, just adjust my screen so I can see this data. All right, so the x values go from 27 to 95. So let's just make the x values here 0 to 100, because we're actually talking about percentage of the carbon-14. And the years here goes from 425 years to 10,000. So the y-axis here, I'm going to go from 0 to, let's go 12,000. Yeah, okay. So let's just take a look here. You know what? I'm just going to zoom out a little bit more. Yeah, so instead of 0, actually, let's go into the negatives here. So for my y here, I'm just going to go negative. And yeah, just curious as to how that looks. Okay, so yeah, so here's my x-axis. So you can see that the carbon here, the graph here, it might look like a linear one, like a straight line. But what we're going to do here is we're just going to model it with a logarithmic function. All right, so so to punch that in, I'm just going to go y subscript 1. Right arrow. All right, so it was a plus b x subscript 1. Nope, that's it. I totally forgot about the log. All right, so we need to type in. Oh no, so to do the log functions, I'm going to have to go here to functions, and I'm going to go to miscellaneous and series or two log functions. So again, we're always going to use the ln or ln. So I'm just going to punch in ln, click that. And this is x subscript 1. All right, cool. All right, so here, yeah, you can see that's a log function. It's a bit of a curve. It's a decreasing one. All right. And yeah, it seems to hit. Actually, it goes through these points pretty nicely. Oh, the r squared is 1, which means it's 100% accurate, which means that the regression model here that we actually came up with is like a perfect fit, right? Because it goes through those points perfectly. All right, so that doesn't always happen, but it does happen from time to time. All right, so so to answer this question, determine the equation of logarithmic regression function that models the data. All right, so let's just write this one in. This is going to be y equals. All right, so my A parameter was 38,067.3 plus. My B was -8. Actually, since it's negative, I don't have to write the plus there. Negative 8265.8 ln x. Okay, so yeah, so those are my parameters. All right, so again, I just subbed in y equals, and then my a value is that, minus, since it's negative, 82.65.8 ln x. All right, so this is my logarithmic function. All right, so let's answer a couple of these questions here. All right, a bone fragment with a carved image of mouse discovered in Florida in June 2011. If the carbon dating test indicated that approximately 20.3% of carbon-14 was left, estimate the age of the bone fragment to the nearest 1,000 years. Okay, so they found that the carbon was 20.3%. So that's going to be my x value. And I want to find the corresponding y value. All right, so x equals. All right, so we have this vertical line here. Now you notice that it doesn't actually hit the function on the grid, so we're going to have to adjust this y value as well. So let's do that. I'm going to have to go a little bit higher than 12,000, perhaps. So we'll go to 15. Yeah, so once I go to 15, you can see that you can see the point of intersection. All right, so let's just click on that. So when my x value is 20.3, my y value is 13,182. Blah blah blah. All right, so 13,182 is the approximate age of that sample. 13,182. Right. To the nearest 1,000 years. All right, so about 13,000 years. Right. Next question here. If the skeleton of bison is about 10,000 years old, what percentage is the nearest carbon? All right, so here we're going the other way. So if I know the age, and the age again was 10,000 years, so y equals 10,000. We want to find the corresponding percentage of carbon that should be there. If I click on this, 29.83. All right. So approximately 30% to the nearest whole number. Okay, so yeah, so about 30%. All right, so yeah, so that's that. All right, so we just, again, punch this table into Desmos, come up with a regression function, and then find those points of intersection on the graph. Cool. All right, guys, so that's, yeah, using logarithmic functions to model data. Ciao.